9. Ratio and proportion. Introduction. In previous classes, we have learnt the concept of ratio and proportion. Let us have a brief review of the same and then learn the application of these in solving the problems that we come across in our daily life. There are two ways of comparing the quantities in terms of their magnitude measurements: comparing by difference, comparing by division. Let us consider an example. The height of Suhail is 152 centimeters and the height of Sushil is 160 centimeters. Since difference in their heights is 160 minus 152 centimeters, which is equal to 8 centimeters, we can say Sushil is 8 centimeters taller than Suhail. This is known as comparison by difference. We can also interpret or compare by dividing 160 upon 152, which is equal to 20 upon 19, and say Sushil's height is 20 upon 19 times the height of Suhail. This is known as comparison by division. Ratio. When we compare two quantities of the same kind by division, we form a ratio of the two quantities. We use the symbol to express a ratio. We can say that the ratio of the height of Sushil to that of Suhail is 20:19, which is read as 20:19. It is evident from above discussion that ratio is a fraction that tells us how many times a quantity is of another quantity of the same kind. In general, the ratio of two numbers a and b not equal to 0 is a upon b and is denoted by a is to b. In the ratio a is to b, the quantities numbers a and b are called the terms of the ratio. The first term a is called the antecedent and the second term b is called the consequent of the ratio. A ratio does not have a unit itself. The order of the terms in a ratio is very important. The ratio a is to b is not the same as b is to a. Examples. Find the ratio of 2 kilometers to 500 meters. Solution. 2 kilometers is equal to 2 into 1000 meters, which is equal to 2000 meters. Thus, 2 kilometers is to 500 meters is equal to 2000 meters is to 500 meters, which is equal to 2000 is to 500, which is equal to 2000 upon 500, which is equal to 4 upon 1, which is equal to 4:1. Remember, to compare two quantities, the units must be the same. Example 2. Asha earns Rs 950 per week and saves Rs 150 per week from her income. Find the ratio of her savings to her income, her savings to her expenditure. Solution. Total income Rs 950. Total savings Rs 150. Total expenditure is equal to Rs 950 minus Rs 150, which is equal to Rs 800. The ratio of her savings to her income is equal to Rs 150 is to Rs 950, which is equal to 150 is to 950, which is equal to 150 upon 950, which is equal to 150 divided by 50 upon 950 divided by 50, which is equal to 3 upon 19, which is equal to 3:19. The ratio of her savings to her expenditure is equal to Rs 150 is to Rs 800, which is equal to 150 is to 800, which is equal to 150 upon 800, which is equal to 150 divided by 50 upon 800 divided by 50, which is equal to 3 upon 16, which is equal to 3:16. Equivalent ratios. A ratio obtained by multiplying or dividing both the terms of a given ratio by the same non-zero number is called an equivalent ratio. Consider the ratio 8:12. 8:12 is equal to 8 upon 12, which is equal to 8 into 2 upon 12 into 2, which is equal to 16 upon 24, which is equal to 16:24. 8:12 is equal to 8 upon 12 is equal to 8 divided by 2 upon 12 divided by 2, which is equal to 4 upon 6. which is equal to 4:6. 8:12 is equal to 8 upon 12, which is equal to 8 into 3 upon 12 into 3, which is equal to 24 upon 36, which is equal to 24:36. 8:12 is equal to 8 upon 12, which is equal to 8 divided by 4 upon 12 divided by 4, which is equal to 2 upon 3, which is equal to 2:3. Thus, 16:24, 4:6, 24:36, and 2:3 are equivalent ratios of 8:12. If A is to B and C is to D are the two equivalent ratios, then A upon B is equal to C upon D. In general, A is to B is equal to AC is to BC, or A upon D is equal to B upon D, where C and D are the non-zero quantities by which we multiply or divide the ratio. Example 1. Find the three equivalent ratios of 8:10. Solution. 8:10 is equal to 8 upon 10 is equal to 8 divided by 2 upon 10 divided by 2, which is equal to 4 upon 5, which is equal to 4:5. 8:10 is equal to 8 upon 10 is equal to 8 into 2 upon 10 into 2, which is equal to 16 upon 20, which is equal to 16:20. 8:10 is equal to 8 upon 10, which is equal to 8 into 3 upon 10 into 3, which is equal to 24 upon 30, which is equal to 24:30. Hence, 4:5, 16:20 and 24:30 are three equivalent ratios of 8:10. Example 2. Fill in the following blanks. 14 upon 18 is equal to upon 9, which is equal to 21 upon. Solution. 14 upon 18 is equal to upon 9. Let the missing number be x. Therefore, 14 upon 18 is equal to x upon 9. This implies x into 18 is equal to 14 into 9. This implies x is equal to 14 into 9 upon 18, which is equal to 7. Let the missing number be y. Therefore, 14 upon 18 is equal to 21 upon y. This implies 14 into y is equal to 21 into 18. This implies y is equal to 21 into 18 upon 14, which is equal to 27. Hence, 14 upon 18 is equal to 7 upon 9, which is equal to 21 upon 27. Comparison of ratios. We know that ratio can be expressed as a fraction. Two fractions can be compared. Similarly, two ratios can also be compared. Thus, to compare two ratios, we first express them in the fraction form and then compare. Example 1. Compare 7:6 and 3:2. Solution. 7:6 is equal to 7 upon 6 and 3:2 is equal to 3 upon 2. Therefore, 7 upon 6 is equal to 7 into 1 upon 6 into 1 is equal to 7 upon 6. LCM of denominators 6 and 2 is 6. 3 upon 2 is equal to 3 into 3 upon 2 into 3, which is equal to 9 upon 6. Now, 9 upon 6 greater than 7 upon 6. Since 9 greater than 7, this implies 3:2 greater than 7:6. Example 2. Which ratio is larger, 5:4 or 9:7? Solution. 5:4 is equal to 5 upon 4 and 9:7 is equal to 9 upon 7. Therefore, 5 upon 4 is equal to 5 into 7 upon 4 into 7, which is equal to 35 upon 28. LCM of denominators 4 and 7 is 28. 9 upon 7 is equal to 9 into 4 upon 7 into 4, which is equal to 36 upon 28. Now, 36 upon 28 greater than 35 upon 28, 36 greater than 35. This implies 9:7 greater than 5:4. Miscellaneous examples. Example 1. Express each of the following ratios in the simplest form. 360:450. 3 days is to 60 hours. Solution 1. 360:450 is equal to 360 upon 450, which is equal to 360 divided by 90 upon 450 divided by 90, which is equal to 4 upon 5, which is equal to 4:5. 2. 3 days is to 60 hours is equal to 3 into 24 hours is to 60 hours. 1 day is equal to 24 hours, which is equal to 72 hours is to 60 hours, which is equal to 72 is to 60, which is equal to 72 upon 60, which is equal to 72 divided by 12 upon 60 divided by 12, which is equal to 6 upon 5, which is equal to 6:5. Remember, a ratio A is to B is said to be in simplest form if the HCF of A and B is 1. To reduce a ratio A is to B in simplest form, we divide each of its terms by HCF of A and B. Example 2. Divide 1500 rupees among A, B and C in the ratio 2:5:3. Solution. Sum of the terms of the ratios is equal to 2 plus 5 plus 3, which is equal to 10. A's share is equal to rupees 2 upon 10 into 1500, which is equal to rupees 300. B's share is equal to rupees 5 upon 10 into 1500, which is equal to rupees 750. C's share is equal to rupees 3 upon 10 into 1500, which is equal to rupees 450. Proportion. Consider the following example. 4 notebooks cost rupees 60. Then the cost of 12 notebooks will be rupees 180. Notebooks 4 is to rupees 60. Notebooks 12 is to rupees 180. We observe that the ratio of the first two numbers is equal to the ratio of the third and fourth number. Such an equality of the two ratios is called a proportion. In general, the numbers A, B, C, D are said to be in proportion if the ratio of the first two numbers is equal to the ratio of the last two numbers. That is, A is to B is equal to C is to D, where A, B, C, D are the first, second, third and fourth term respectively. Or A is to B is to C is to D, which is read as A is to B as C is to D, or A to B as C to D. The symbol represents proportion. The first and fourth terms of a proportion are called extreme terms or extremes. The second and third terms of a proportion are called middle terms or means. The product of extremes is equal to the product of means. A is to B is equal to C is to D. This implies A upon B is equal to C upon D. This implies A into D is equal to B into C. Continued proportion. If A is to B is equal to B is to C, then A, B, C are said to be in continued proportion. C is the third proportional to A and B. B is called the mean proportional or geometric mean between A and C. A is to B as B is to C. This implies A upon B is equal to B upon C, or B squared is equal to AC. Example 1. Which of the following are in proportion? 1. 10, 16, 5, 8, 2, 15, 20, 4, 3. Solution. If 10, 16, 5, 8 are in proportion, then 10 is to 16 as 5 is to 8. Product of extremes is equal to 10 into 8, which is equal to 80. Product of means is equal to 16 into 5, which is equal to 80. Product of extremes is equal to product of means. Hence, 10, 16, 5, 8 are in proportion. If 15, 20, 4, 3 are in proportion, then 15 is to 20 as 4 is to 3. Product of extremes is equal to 15 into 3, which is equal to 45. Product of means is equal to 20 into 4, which is equal to 80. Product of extremes not equal to product of means. Hence, 15, 20, 4, 3 are not in proportion. Example 2. Find the fourth proportional to 7, 3 and 42. Solution. Let the fourth proportional to 7, 3 and 42 be x. Then 7 is to 3 as 42 is to x. This implies 7 into x is equal to 3 into 42. This implies x is equal to 3 into 42 upon 7, which is equal to 18. Hence, fourth proportional to 7, 3 and 42 is 18. Keeping things in proportion and getting solutions. We have studied in previous class that if the cost of one article is given, then the cost of certain number of such articles is equal to cost of one article into number of articles. Conversely, if the cost of certain number of articles is given, then cost of one article is equal to cost of given number of articles upon number of articles. A method in which the value of unit quantity is first obtained to find the value of any required quantity is called unitary method. In solving problems on unitary method, we come across two types of variations: direct variation or direct proportion, inverse variation or indirect proportion. Direct variation. When two quantities x and y are such that the ratio x upon y remains constant, then we say x and y vary directly. Examples: the cost of articles varies directly as the number of articles. More articles, more cost. Less articles, less cost. The work done varies directly as the number of men at work. More men at work, more work. Less men at work, less work. Example 1. The cost of 8 books is Rs 72. Find the cost of 20 such books. Solution. Cost of 8 books is equal to Rs 72. Cost of 1 book is equal to Rs 72 upon 8, which is equal to Rs 9. This implies cost of 20 books is equal to Rs 9 into 20, which is equal to Rs 180. Alternative method. Proportion method. Let the cost of 20 books be Rs x. 8 upon 72 is equal to 20 upon x. This implies 8 into x is equal to 20 into 72. This implies x is equal to 20 into 72 upon 8, which is equal to 180. Hence, the cost of 20 books is Rs 180. Example 2. 15 men construct a wall 20 meter long in a certain time period. Find the length of the same wall to be constructed by 12 men in that period. Solution. 15 men construct wall of length 20 meter. 1 man construct wall of length is equal to 20 upon 15 meter. Less men, less length. This implies 12 men construct wall of length which is equal to 20 upon 15 into 12 meters. More men, more length, which is equal to 16 meters. Hence, 12 men will construct 16 meters long wall. Alternative method. Let the length of the wall be x meters. 15 upon 20 is equal to 12 upon x. This implies 15 into x is equal to 12 into 20. This implies x is equal to 12 into 20 upon 15, which is equal to 16 meters. Inverse variation. Two quantities are said to be inversely proportional to each other if increase in the value of one quantity results in the decrease of the second quantity and decrease in one quantity results in the increase of other in such a way that their product always remains constant. When two quantities x and y are such that xy remains constant, then we say that x and y vary indirectly. Example 1. If 10 men can construct a house in 156 days, how many men are required to construct it in 120 days? Solution. In 156 days, house can be constructed by 10 men. Less days, more men. In 1 day, house can be constructed by 10 into 156 men. This implies in 120 days, house can be constructed by 10 into 156 upon 120 men, which is equal to 13 men. More days, less men. Alternative method. Number of men, 10. Number of days, 156. Number of men, x. Number of days, 120. Therefore, 10 into 156 is equal to x into 120. Inverse proportion. This implies x is equal to 10 into 156 upon 120. This implies x is equal to 13. Hence, 13 men are required. Example 2. If 25 men can reap a field in 42 days, in how many days will 30 men reap the same field? Solution. Number of men 25, number of days 42, number of men 30, number of days x. Therefore, 25 into 42 is equal to 30 into x. This implies x is equal to 25 into 42 upon 30, which is equal to 35 days.